This is 3.6 college algebra. We'll call it video A. We'll see if we need to get through this, but we're on page 320 of the book. And this is polynomial and rational inequalities. Okay, so what we're going to do is we're going to look at inequalities instead of what we have been looking at as far as equations are concerned. And the only difference is that we have an inequality sign instead of an equal sign. But what we're doing is we're looking at the border of the area that numbers work. So what we've got here is we've got a line that we're going to get, a graph that we're going to get of this equation that is going to be the border. Now we're either going to take inside that graph or on the outside of that graph, but either way we're going to be looking at that graph and then make some decisions based on that. Alright, so one of the key things you need for this, and make sure you write this down, is we're going to basically replace every equation with a y. So this one right here says, I want to know what the x values are such that y is less than 0. So in other words, what I'm looking for is a graph here where, let's say, the graph looks like this, which it does. If you look on page 320 at the bottom, it looks similar to that. What this is saying is, I want to know what values I can put in for x so that my y is less than 0. So I'm only interested in this part of the graph where my y is below the x-axis, when my y is less than 0. That's what I'm looking at there. If I were to take the sign and change it around to a greater than sign, I would be looking at the values for x that I put in so that y is greater than 0. Okay, so what I'm looking for is above and below the x-axis. So what we're going to do that is we're actually going to write this as f of x equals x squared minus 4x minus 5. Okay, so we're going to write it as an equality like that so that we can find a graph and then we can make some determinations from that graph. Okay, so we find out that x squared minus 4x minus 5 breaks down into two factors, x plus 1 and x minus 5, just using real easy factoring. It tells me that my zeros then are negative 1 and 5. So it tells me it crosses. Actually, my graph is not a very good graph. Let's get a better graph here that more accurately represents what I'm doing here. Okay, so I've got my graph and it crosses, what did I say, negative 1 and positive 5. So here's my graph. Okay, so right there's my negative 1, right there's my positive 5. So those are my zeros. The x-intercepts of the graph are negative 1, 0, and 5, 0. So now all I have to do is write my intervals. So my one interval is from here over here. My other interval is between 5 and negative 1, and my other interval is greater than 5. So my intervals are negative infinity to negative 1, negative 1 to 5, and then 5 to infinity. So those are my three intervals that I'm interested in looking at. So now all I have to do is take a number that fits into this category, throw it up into this equation, and see what I get. And I don't care, again, I don't care what the answer is. All I care about is it a positive or a negative sign? So I'm looking for everything from negative infinity to negative 1, so let's put in a negative 2. So that gives me negative 2, the quantity squared, minus 4 times negative 2 minus 5. And I find out when f is negative 2, my y value, or my answer, is 7. So what I've discovered then is that to the left of my graph, or over this direction from my x-intercept, all of the y values I get are going to be positive. Okay, that's all I care about. I got the number positive 7, but I don't care about the 7. I just want to know, am I above or below the x-axis? Is the graph above or below the x-axis? So now I look at this interval, negative 1, 5. I grab a number, probably the easiest one is 0, and I plug 0 into this equation here, and when I do, it spits out a negative 5. That tells me that the sign in this interval between negative 1 and 5 is negative. And then I look and try to see a number greater than 5. So I plug one of those numbers in, and what we're going to do is just put in 7. So when I put in 7 here, it gives me 16, clear up here. So I'm above the x-axis there. So that's all I was looking for, is in the intervals, which intervals were positive, which ones were negative. And the question then is, when is my y value, okay, again, the inequality we have here, when is my y value less than 0? So when is my up and down smaller than 0? Well, here it is 0. Anything above here would be greater than 0, so down here would be all my negatives. So my solution set would be between negative 1 and negative 5, my y value, between negative 1 and positive 5, my y value is going to be 0. Or I could write it in set builder notation as x such that x such that negative 1 is less than x, which is less than 5. Either one of those, depending on what they're asking for. If they ask it in set builder notation, it's this one. If they ask it in interval notation, it's this one. Okay, so let's try another one. So this one is asking me, this is example 2 on page 321, when is y greater than 0? So again, we're looking at the whole equation with the x, and we're saying, okay, when is this answer going to be greater than 0? So what numbers can I put in here for x such that when it spits out, our y value is going to be greater than 0? Okay, so let's do the math. Factor out an x. We've got x squared minus 1 equals 0. So again, we're making it into an equality. And then I've got the difference of two squares. So I've got x plus 1, x minus 1 equals 0. Okay? And that tells me right there that my zeros are 0, negative 1, and positive 1. Okay, so I have 3 zeros there. Okay, which makes it so, let me erase all of this so I have a little bit more room to graph here. It makes it so I have 4 intervals. And my intervals are going to look like this. I've got a negative infinity to negative 1. I've got negative 1 to 0. I've got 0 to positive 1. And I have 1 to positive infinity. So I have 4 different intervals. So what I'm interested in is in these intervals, which intervals have positives and which ones have negative y's, because I'm looking for the positive y's. In the original equation, it said, when is my y going to be bigger than 0? So which intervals is my y going to be bigger than 0? That's what I'm looking for here. So I'm going to grab a number. So let's say I put a negative 2 in to find out what that interval does. When it spits out an answer, it gives me a negative 6. So that means my y value is below the x-axis there. Then I put in a number between -1 and 0. So I'm going to have to stick in a fraction, so let's put in -1/2, and it will spit out a positive answer when I do that. So I get a positive answer here. I don't care what the answer is, I just want it to be positive. Then I put a number between 0 and 1 here, and again let's put in a positive 1/2, and I do that and I find out my answer is negative. And then I put in a number here somewhere between 1 and infinity, and the book put in 2. It kicked out a positive 6, so that gives us a positive. So what we're interested in is when is y above the x-axis, greater than 0? Well, here and here. So this interval and this interval, it's going to be above the x-axis. So you could write for an answer, -1, 0, unions, 0, 1. I'm sorry, 1 infinity. That's where it's positive. Alright, try that again. 1 infinity. Okay, you can also write this as x such that -1 is less than or equal, or is less than x, which is less than 0. So that takes care of this one. And, or, because and we would write differently, x is bigger than 1. So those are your options. So this one right here associates itself with this part, and this associates it with this. And this just says x is greater than 1 because it goes to infinity. So there's no stopping point. Like there was a beginning and a stopping point for this one. X had to be between there. But here, the x is not between anything. It's just bigger than 1. So you don't have to write 1, 2, 3. It's just this one right here. Okay? So that's example 2.